Hey, welcome to my favorite and final section of Maths&Tricks. And this is solving partial differential equations using finite difference method that has already been introduced. Now there are three different types of partial differential equations, namely elliptical, parabolic, and hyperbolic. The difference between ordinary differential equation and partial differential equations is that ordinary differential equation takes the ordinary derivatives with respect to a single independent variables, while partial differential equations take derivatives with respect to several variables, and obviously the derivative is partial. Let me talk about elliptical equations first. The typical example of an elliptical equation is the Laplace equation. This equation was studied by Laplace in 1780, which represents the special coordinates x and y and maybe z. The physical interpretation would be the mechanical and thermal equilibrium. The Laplace equation gives the shape of the object, such as displacement of each point at mechanical equilibrium under stresses when the action and reaction balances out using the boundary conditions which must be known. Similarly, if it is a thermal equilibrium, it would give you the profile for temperature distributions. Remember, I used the term equilibrium under constant heat supply. In other words, the inflow becomes equal to the outflow. Now let's go through an example. Say the dependent variable u, which can be displacement or temperature, is differentiated with respect to two independent variables such as x and y and spatial coordinate system. The boundary limits and conditions are given. Let me show you how to specify the upper, lower limits and boundary conditions. As it's a two-dimensional problem, so make a discretization in a plane. So you can see clearly that there are only three unknown nodes, such as node 22, 23, and 24. The boundary conditions is not directly given, but rather in terms of independent variables such as x and y. But as the step size is known in both directions, which is 0.5, so we can find the values at each boundary node. Now going back to the given partial differential equation, use the central divided difference formula in the xy coordinates. H is for the step size in the x direction. K is for the step size in the y direction. In this case, as they are equal, so can be cancelled out. Here we too have the same concept of governing equation, and from this equation we can get expression for node 22 at x equal to 0.5 and y equal to 0.5. Node 23 at x equal to 0.5 and y equal to 1. Node 24 at x equal to 0.5 and y equal to 1.5. So having these three linear equations for the three unknown points, write in matrix form and solve for U22, U23 and U24. Now you must see how simple it is. And computer solving approach such as NMATLAB, Mathematica, ANSYS or Abacus, all these follow this sort of techniques, which may be finite difference techniques, which may be finite element techniques, which may be finite volume techniques, and generates metrics not 3 by 3, but rather 100,000 by 100,000s, and still we get the approximation, never the exact solution. Thanks for watching.